welcome back. We'll just do our usual intro about DataMine, just for all the new people who have decided to come to this webinar. For those that don't already know, we are a global company and have many locations all around the world. If you are located outside of Australia and you have any questions, please feel free to reach out to your local office where you'll get support in your own region and language. Once again, for those who are not familiar with Studio RM Pro, it is made up of 3 different standalone products. So Studio RM, Status Neo, and Supervisor. They can be purchased separately or as the bundle that we're calling Studio RM Pro. This makes the ultimate best-of-breed package we have to offer in the resource estimation and evaluation chain. Studio RM Pro strives to be the best and only solution you need to understand and evaluate your mineral resource. With the bundle, you have access to the best tools of each product to use to resolve issues that you might encounter while you are doing your resource estimation. We are now up to week 4 of our 5-part webinar series. Previously, we have covered our data interpretation and geological modeling in week 1. In week 2, we did our EDA and variography. Week 3, we are creating our block model and estimating. And today we will be covering model validations in Studio RM and Supervisor. And the following week, we will be looking at conditional simulation. Now, where are we in the workflow? We are here. We're nearing the end of our estimation workflow, so there's not much for us to cover. Typically with model validation, we find clients will do a minimum of at least doing their visual checks, running slough plots or trend plots. They're the same thing, just depends what you call them, wherever you're located around the world. We typically check our model statistics as well as comparative stats between model and comp. And obviously we do ton grade curves. There are obviously many other validations you can do, and some of them will be maybe operations or deposit specific. So it's important that when you do the validations, you're doing the ones that are also relevant to your deposit that you're estimating. So in summary, model validation involves verifying the accuracy and reliability of the resource model in predicting the grade. This is important because that means we can trust the model to make decisions that we need for in whichever part of the mining cycle that we're in. So for example, if we're updating a grade control model for a narrow vein deposit, you want to be able to trust the model is good enough to use for selective mining. So we can use the model to go, right, which stopes are we going to take? What are we going to leave behind? We're going to go through the following steps here. So we'll do the visual checks, summaries, trend plots, histograms, probability plots, and grade tonnage curves. We're also going to use Studio RM. So when we're using Studio RM, we're going to use Studio RM for the visual capacity that it has. So we'll step through our data and we'll quickly run through how to use legends and templates and some of the clipping tools. We'll also go through show sample, and this is a tool that allows us to interrogate the block of the model to see which samples were used in the estimation. And we'll run through summary statistics. So this is just a nice process to run just to get a global understanding of what's happening in the population. Also allows you to pick up absent grades and negative grades. So it's a little red flag, is a nice little tool to use to just flag whether or not you have these issues. Then we'll jump into Supervisor, where we'll import the comps and block models from Studio RM into Supervisor, and we'll use the model validation tool, also a very popular tool in Supervisor that clients often use. And this will quickly and easily provide information, charts, and various other items that will help us understand how our model has performed globally and locally. So without any further ado, we will start the demo, and I'll just turn off my camera so I don't end up lagging, and we'll kick off. All right, so last week when we were using Studio RM, we made our model, so we're in model validation, and we built our volume model. And then we set up our model to parameters of the parameters that we were going to use to estimate. That was last week. Last week, we only estimated the copper in the last estimation. Before this webinar, I actually ran back and set up the estimation so that I ran copper, arsenic, and silver. So I've got a lot more fields in my model now. So I ran an ordinary Krieg model for silver, arsenic, copper, and for copper, I ran an additional inverse distance and nearest neighbor. And so the model that I now have is this model here, which I will click and load. So this is the model I have, and the comps I have used are the same comps like so. So you can see through here, this is my drill hole data, and this is my model data. So one of the very classic things we do is like we want to step through our data set and just look at how our model has performed accordingly in comparison to our drill hole files. So everything is currently a default setting. So what I'm going to do is I'm just going to look down onto my data set. So I've just hit Shift Z, so that means that's the quick key to just look on plan view. And I'm going to hit the number 1. And so the number 1 is snap to 1 point. So you can snap to 1 point, 2 points, or 3. So I'm going to just right click, snap to 1 point, and I'm going to go east-west. And I'm going to hit AVW, which is align to view. And now I'm looking at my data set in section. To get my view to the way that I want it to look, I've built some legends and templates already. And if you've already done that, you know that you can easily retrieve them. So if I click on block model CU, I can see that this is my template. And if I decide to clip my view, I've used a quick key and I've clipped my view. So now my block model is in section, and as are my drill holes. If I go to the view ribbon and I want to increase my clipping, I'll just change that to 40. And you can see through there, I have my block model and my drill holes clipped to a certain view. To get my block model view, all of this is done within the block model properties. So I've set this up for copper, but if I wanted to set this up for another element, the quickest way to do it is to hit the drop down, click on a element that you want to interrogate. So in this case, silver. I'll hit the icon with little star, which then takes me into this little area here. And this is a legend of my block model grades that is silver. I'm going to take the defaults for what they are. And what you will see here is a little graph of all my data for that estimation. In columns, if I change that to 60, or break it further down into additional bins, and you have different options to choose how you are going to break down this information. I'm just going to go linear equal population. I'm going to have 10 bins, and I'm going to have a decimal point of 1. And then you can set a range. So in through here, you can see that I have negative grades, which is not ideal, but I'll sort them out later. And I want 10 bins to 1 decimal place, ranging from 0 to 250 to 500. That will do me. And I'll hit create ranges. In through here, I'll create my ranges. If I wanted to change them visually, I can just click and drag, or I can just hit the numbers in through there. Once you're done, you just hit finish. And if I click apply now, you can see that the blocks around the view have changed colors. Now, the label that I currently have on is copper, which is not what I want because I now am looking at my silver. So I'm going to turn off copper, but what I will do is I will click new, and this will allow me to build my labels. And so I'll just stick in silver, 1, hit insert. I want it to display in center, and then I want the color to be from my silver column and my silver block model legend. And you can see that it's displayed like so. In through here, there's the info mode list. So far it has geology and copper, but if I click my silver, and arsenic and hit the down arrow and hit apply, all that means is that when I go to query, so I'm going to hold down shift on the keyboard and question mark, and I click on my block, the little drop down will be what has been listed in the info mode list. Now, if I wanted to use this setup again, what I can do is I can create a new template. So I'm going to do one here, and this is going to be for silver, and it's for ordinary kriging. And I'm going to update the selected template, and then I'm going to export. And I will export in webinar week 4. So this means that I can give this template to someone else in my team to use, or I can recall it again. I'm just going to go back to my sheets, right click, use templates, and go back to my CU OK. So creating your legends and creating your templates is how you are going to manipulate your view. I've already done one for my comps, and I will do it like so. And what people typically do is that you will just step through your data set to see that the blocks are within a similar range to your draw holes. And usually it's a red flag if you have blocks that are high grade, but the sample surrounding it is low grade, and that's a red flag to kind of interrogate that area and see what's going on. Some people, when they're looking at the data like this, I've simply clipped the data set, so that's the clipping there. Sometimes you might not want your clip applied, but you want something, but you want other elements. So let's say that I was also interested in looking at my wireframe, and you can see that my wireframe is clipped, but I want a smaller clipping. So let's say it's 10. I'll change that to 10 and hit enter. But I don't want my draw holes clipped. So if I go to Sheets and I right click on my draw holes, there's a, down on the menu, there's Apply Clipping. If I take off Apply Clipping, it means everything else is clipped except for that element. So this means that I can have certain things that are clipped to the global clipping, and I can take things off. When the object is underlined, it means that it is off the global clip. So I'm just going to turn it back on, like so. Another tool that people find useful is these tools here. So model is new. So people that know about this, with the wireframe, you can see that it is surfaces, but if I click on the wireframe, it will change it to a string. Now, if I was viewing my model not as intersection, but as blocks, and I'll just click apply and go OK. And let's say that I had a clipping window of 50. And I go back to format. We have the same thing for model. So now when I click model, it will change it, toggle between it being blocks and intersection. And I've got the same tool for wireframe. So those tools can be used to help you just quickly flicker between 3D and 2D. All right. So once you've stepped through your data and gone visually, oh, look, it looks all right. One of the other things we can do is interrogate the model to see what samples were used. Now, in order to do this, when we estimated the model, obviously you have the block model, but you need to have also produced the sample file. So if I go back to my estimate ribbon and go back to the advanced module and go, and I'm down in run estimation, there was an option here to produce a sample file. You must produce this in order to use the show samples. If you do not produce the sample file, you cannot use this tool. So to use this tool, you must have the block model and you must have its associate sample file. Now, the sample file was this file here, and it's effectively a points file. It's got the coordinates of your points, and it's also got the coordinates of your block centroids. When you spit out a sample file, it will produce a folder, a single file with every single estimation type that you have used. And let's say I'm only interested in interrogating the block model with my copper and the ordinary Krieg estimation. So I need to strip this down so it only has CU OK. what you need to do, is you use an extra statement to do that. So to do that, simply select your sample out, select the output file, hit OK. Clean it up, so just reference the fields that you want to keep. I won't run it because I've already done. And you will spit out the file that you can now use. And you can see that in this particular file, I only have CUOK, and that's the only field in this file. I'm going to click and drag this in. So even though this file has two coordinate systems, it will come in as a point file. I'm just going to apply a template on this. So it will display my points slightly bigger, and it will also have the grade of my samples on the left-hand side. And you can see that now that both these objects are loaded in the 3D viewer, does this icon turn come up? If I hit it, my points file, or if I did not have my block model or points file loaded, you would see this turn gray. Cool. If I did not have my block model or points file loaded, you would see them turn gray. You would see this object turn gray. So both must exist in the screen. Yeah. I'm just going to click on the icon. It's active because it will ask if I'm done with the tool. I'm not. And I'm just going to just randomly click in a block up here. So it's asking me to select a block. Now that I've selected a block, you can see that the dimensions of that particular block are highlighted, and only the samples that have been used in the estimation appear. So it's a really nifty little tool just to be able to interrogate the blocks in your model and to see what samples have been used to estimate the blocks, and that the sample selections fit the parameter criteria that you set up during your estimation. And so you would obviously run through and do all these things. All right. So once we step through and section through our model, and once we've interrogated what samples been used in our blocks, another useful tool in StudioRM is our summary statistics. So summary statistics is in sample analysis in the statistic processes, and it's the first one in the drop-down menu. So this will just give us like some nice global stats. So I'm just going to reference my model, my output, reference my estimations that I'm curious about based on my domains. So key one is my domain, and then my F fields are my assays, or my estimated fields. I'm not going to run this because I've generated it previously. Excuse me. And here's one I prepared earlier. So I have it spat out based on the type of estimation and also by domain. And so it gives you the number of records, my min, my max, my total, my mean, my variance. And useful things to take out of it is that it will also highlight if I've got negative grades. You can see that copper does not, but if up in my silver grades, I do have negative grades, which is an issue. So that's something that I would need to address. All right. If you find that you have negative grades in your estimation, the easiest way to deal with them is to obviously run an extra statement. So if I wanted to replace anything in my block, simply use an extra statement. So if your field is less than, or if it's absent, replace with a lower detection limit. And that value might be 0.01 or 0.005. That is up to effectively the deposit that you're in and your assigning techniques. All right. The next thing I'll run through now is we'll actually jump into Supervisor to run model validation. I'll just minimize GeoRM and I will pop over Supervisor. I've got something prepared already, but that's okay. We can rehash again. The nice thing about StudioRM and Supervisor is they talk well to each other. So I'm going to do the same thing that I did previously. And obviously you can click and drag your data in. It will field match to whatever you need to field match. And I'm going to detach, and I'm going to do this via assay domain. And I will load my data. And I will do the same thing for my block model. So I've clicked and dragged my block model, and then it's field matched. I will detach, and because I'm doing model validation and with my comps, I've loaded them as domain over assay. I'm going to do the same thing for the block model. So I'm going to do that as domain over assay. And once that's done, I'm just going to click load data. Yeah. Now, once I've loaded my data, let's say I wanted to do my model validation for shear A on copper. Just click copper, and you can see there are multiple options that you can choose from, and I am going to click model validation. And the nice thing about model validation is that when you activate it, it automatically sets up the templates for your trend plots, histogram, probability, QQ plots, gray ton curves, and statistics. So it's all there ready for you to just load up your data. I'm going to load up my model. So this is model number 2. And I'm going to check out my copper. So I did a estimation of a copper ordinary creek, and I also did one of my inverse distance and a nearest neighbor. And let's say for whatever reason, I was trying to choose which one to use. So once I've referenced my data, I'm just going to update everything. Oh, and hopefully this thing won't shut down on me. It's trundling away. It's trying its best. Okay, so what do I have here? Cool. All right. So I've hit update everything. It's done my XYZ. It's struggled on my cross reference. You might not be happy with how I've set this up, but that's all right. We won't worry about that for now. So it does all my major cardinal directions for my trends, my X, my Y, and my Z, and then it will do the strike and a cross strike. With all the plots in Supervisor, they're all dynamic. So you can see that there's a lag here for my slicing. So this is me slicing through the model. And obviously I can play around with the axes accordingly. We can do it for our Y, and then we can also do it for our Z direction. So the nice thing about this is that we have our raw data, so our drill hole data, our comp data in red, and then we have our estimation data in black, gray, and yellow. And it's probably not being happy because my block data for my third one is not very good. So I might just remove this and just run everything again, but I'll just run it on the 2. And we seem to have worked. Okay, so there's something going on with my nearest neighbor estimation. So the main thing about this is that it will slice through my model. And if I go to the view, you can see that this is how it's decided to slice through my composites and my drill holes. And the data in the number of samples is dictated on the right-hand side. And so this is my raw data here. And what we're usually looking for is that if the estimation veers widely from our raw data. And I probably have overestimated in some areas because my estimation is above my raw data or naive mean. But where I have high density data, they tend to match like for like. In through here, the estimation has overestimated quite a fair bit, but considering that this is probably the peripherals of the data set, and also there's not a lot of samples supporting this, it's kind of like, oh, all right, maybe it's not too bad. Typically, a lot of people will use this to look for kind of major inflection differences. So this looks good here, but if I had high density data and my estimation was either overly estimating or underestimating, it might be a flag for me to go back and actually look in this section along Y to see what's going on, to see what's going on, or if how the distribution of the data makes sense. So we have those trend plots, which are really useful. We, of course, obviously have our histograms. So our drill hole data is naturally in red, and then we've got our estimation data like so. We've got our log probability. If you go into the CDF, we've transformed it to log assay and Gaussian frequency. So you got the option to flicker between the two. We've got our QQ plot in through here. So we can compare the distribution of the estimated model versus the composite data and see the frequency of each value of our copper. And then we have our grade ton curve. So there's nothing being displayed. I just need to set the cutoff. So let's say I'm interested to see how it performs between, and I'll just look at my 2 there. So let's say I was interested to see how it performed between 0 and 2 at, let's say, 0.2 increments. If I hit add and then I hit play, you can see that I've got my grade ton curves like so. I also have my statistical comparison plot. So it's my raw data, my block, and the difference between them all. And obviously we can export this out as a CSV and you can use it for something else. Now, something to note, if I've run an ordinary Krieg estimation to properly compare my composites against my model, my composites need to be declustered, because an ordinary Krieging estimation by nature declusters because it takes in the relationship of the sample between the block and the sample via distance, and also takes in consideration sample-sample relationships. So I'm going to add a decluster. So I'm just going to right-click and choose my decluster component. And in through here, you choose various cell size. I will, let's go, that should be fine. Let's go 40 by 40 by 40, and I'm going to click optimize. And it should run. Yep. And then in through here, a rule of thumb that some people use is when it starts to plateau out, they might choose a cell size where it starts to go flat. There's a little tool here where you can actually change the link to like an XY or a ZX or a YZ, so depending on what your data set is, and that might just help you see the trend a little bit better. I'll just randomly click one of these guys. I think something is going a little bit strange. And once you've selected a decluster, we're going to click apply. That's applied. You can see that this is highlighted, so I'm going to run this all again. And when I run it again, you should see that the declustered mean is now an option for us to display. So you can see our raw composite data, our declustered composite data, plus our model estimations of, and in this scenario, we've got ordinary Krieg and our inverse distance. And yeah, so as you can see, like this is the model validation we can do in Supervisor. It's very easy and efficient, and in combination with the visuals, checks, and stats that we ran in StudioRM, we now have a better understanding of how reliable our estimation has performed. And that is effectively our